Hi everybody, Mrs. Pesic here. We are looking at section 12.4. I'm live with block 8. Block 8, you want to give a little shout out? All right, so in this section, we're looking at section 12.4, inscribed angles. You're going to find the measure of an inscribed angle, and you're going to use inscribed angles and their properties to solve problems. So what is an inscribed angle? An inscribed angle is an angle whose vertex is on a circle, as opposed to being in the center of the circle, right? And whose sides contain chords of the circle. All right, so this angle here, angle DEF, is an inscribed angle. All right, its vertex is a point on the circle. Our definition for central angles, if you recall from earlier in this chapter, central angles would have their vertex as the center of the circle, right? Everybody agree? So this would be an example of a central angle compared to an inscribed angle. All right, all good? So an intercepted arc is going to be the arc that's created by an inscribed angle. So in this case, like this arc DF right here, arc DF, I'm drawing a little arrow, arc DF is an intercepted arc. Intercepted arc. All right? Okay, and we would say, hey, the arc or the chord subtends an angle when its endpoints lie on the angle. So angle DEF is an inscribed angle. Arc DF is the intercepted arc. I didn't even have to write all that out. There it is. And arc DF subtends angle DEF. We're not going to use the word subtends very much, but we're certainly going to use the words inscribed angle and intercepted arc quite a bit. Are we good with this page? All right, moving on. So we have a theorem about inscribed angles, all right, and it says the measure of an inscribed angle is half the measure of its intercepted arc. All right. So in this case, I just want to compare this. You know what? Actually, I'll stop. I want to compare this to the whole idea of central angles. Let's say I have this angle here that measures 80 degrees. So then what would be the measure of this arc? 80, right? But that's if it was a central angle, right? Then the arc measures equal to the angle. Everybody with me? Yeah. But game has changed now. New game. All right, now it's an intercepted arc and it's an inscribed angle. And the measure of an inscribed angle is going to be half the measure of its intercepted arc. All right. This is one of the many formulas that will not be provided for you, but you will need to know on our quest next Thursday. Somebody should be keeping a running tally, all right, because there are a lot, okay? So in this case, you could have a picture like this, or you could have a picture like this, or you could have a picture like this. I don't know why they're making a big difference out of these three cases. This one of the sides of the angle is actually a diameter. In this case, neither of them are a diameter, they're both chords, and here they're both chords, but they're both on the same side of the center. But the formula is still the same. The measure of the angle is going to be half of the measure of the arc. Let's take a look at this example. In this case, we're trying to find the measure of angle RST, and we're trying to find the measure of arc SU. And I'm asking you to help me out with this. Andrew, how are you going to find the measure of angle RST? That's this angle right here. Hold for a second, Andrew. I do want you to notice what's given in this picture. We're given this angle here measures 40 degrees, right? And we're given that this arc here, arc RT, measures 120. So which of those, Andrew, is important for us in finding the measure of angle RST?
We need the arc RT.
The arc RT is important to us because this would be the intercepted arc for this inscribed angle. Does that make sense?
Yeah.
No.
Here is, let me draw this angle. Let me draw segment SR, or ray SR, if you will, and segment ST. Aren't those exactly hitting the endpoints of that arc?
Yeah.
Everybody with me? So, Andrew, what's the measure of angle RST going to be? Is it 120?
Yeah. Oh, wait,
No, it's
multiply
multiplied
by half.
Half of 120, so that's going to be 60 degrees. Are we okay with this? Does that make
Wait,
sense?
can you explain why it's half?
It's the theorem.
Well, I mean,
It's the quick answer is it's the theorem, but it certainly can't equal exactly 120 because, I mean, that would make it an obtuse angle and it doesn't look obtuse,
no, it's not.
right? I think we could reason this out by finding a few more angles. I'm going to erase what I've written up here so we can talk now about finding the measure of arc SU. Here's arc SU. Is that
That'd be 80.
an intercepted arc?
No. No, what's that mean?
Yeah, 'cause
I
it's-
don't understand intercepted arcs.
Intercepted arc.
Oh, arc. Never mind, I get it.
It's an arc. Does it have an inscribed angle that's pointing out to? Yeah, the 40. So,
So it's gonna be 80.
so this angle here is the inscribed angle because its vertex is on the circle. And this arc is the intercepted arc. So its measure must be what? 80. Right?
I understand now.
The angle inscribed angle equals half of the arc, right? So in this case, I was able to say inscribed angle is 40. 40 equals half of the measure of arc SU. So I need to multiply both sides by 2 to get this to divide out, and I get measure of arc SU is equal to 80. Are we okay with that?
Can I also just do 40 times 2?
Yes, this is for educational purposes. Are we okay with this?
Yeah.
All right, moving on. We get some practice here. Find the measure of angle DAE. Measure of angle DAE is this angle right here. Ella, can you help me out?
I said 38 degrees.
How'd you get 38?
I multiplied 76 times 0.5.
All right, so the measure of angle DAE is going to be equal to half of its arc, and its intercepted arc could be arc DE. Everybody agree?
Yeah.
So I'm going to say, the measure of angle DAE is half of 76, and you told me that was going to be 38 degrees. Are we okay with this?
Yes.
We also divide 76 by 2. Or does it have to stay within that?
I think that there's going to be a significant section of this quest where you're going to have to write out, show your work.
That's what I
Okay. All right, how about the measure of arc ADE? I'm erasing what I put up here. If I want the measure of arc ADE, I got to start at A, hit D, and come around and end at E. Wow, that's a really sloppy arc.
C.
But that's because I'm so short. Okay,
No,
It's C.
it's C.
so,
Ended at C.
wow.
And at E.
Yeah, you have to go just
To
like
go a
an inch
little
like
bit more.
inch more. No.
We're at E.
This is point C.
Yeah, you're not.
That's where you're supposed to go.
Oh, my bad. Is it better?
Yeah.
Wait, can you change the dot? So it's
Oh my God.
Let me just get rid of that dot.
How's that? Yeah, there you go. Better.
Blue dot to blue dot. Okay, are we okay with this?
Can I explain it?
I'm going to call on somebody. Maybe it'll be
Maybe a question.
It is not. It is not Evan either. Rachel. Rachel, we have, if this all hooks together, which of course it's not going to, we have this nice arc, and it's an intercepted arc for what angle?
Angle A.
Yeah, I would think this angle ABC here right? Doesn't that hit my two endpoints, right? Here. So we're going to say the measure of angle ABC is equal to 1/2 of the measure of arc ADC. Would you agree with this?
Yeah, good.
And so what am I filling in here? 135 equals 1/2 the measure of the arc. True?
Yeah.
So what's the measure of the arc going to be? Do I need to multiply by 2?
No, divide. Yeah, multiply by 2.
Multiply by 2. So do I get 270
No.
is the measure of this major arc ADC? Are we okay with this?
Yes.
Awesome. Okay, moving on. Let's take a look at this corollary. If inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are going to be congruent. All right, so this is kind of a cool thing because we have, in this case, we've got, let's say, angle ADB. I'll draw over angle ADB in blue here. Angle ADB, and let's say we also have angle ACB that I'm drawing over here. These two angles that I drew are actually going to be congruent. Why are they congruent? How do we know they're going to be congruent?
Because they're intercepted at arc AB.
They're hitting the same arc AB. So if arc AB was, I'll say 100 degrees, if the measure of that arc was 100 degrees, what would be the measure of both of these angles? They would each measure 100. They each measure 50, right? Does that make sense? This one would be 50 degrees. This one would be 50 degrees also. Are we okay with this? That's what this theorem is saying. If you've got two angles, two different angles like this, two inscribed angles that are hitting the same arc, they're going to be congruent. Moving on. All right, so we have this cool thing, drag for a simpler diagram. So if the measure of angle we're supposed to find the measure of angle DEC.
Yeah.
Do you have this?
Yeah.
Like this?
We don't, yeah.
Okay, so we have this picture. Find the measure of angle DEC if the measure of arc AD is 86. So here is it drawn a little bit better. Angle DEC is what we're trying to find. That's this angle here. If the measure of arc AD is 86, that's this arc here is 86. Agreed?
Yeah.
And we do see that this angle here is 60. Interesting problem. Interesting problem. Well, I think if this is 60 right here, tell me what's the measure of an arc that you know? What's the measure of an arc that you can determine here, Isabel?
I would say that arc CB is 120 degrees.
Would people agree that this arc here, from here to here, is going to have to be 120 degrees?
Yeah.
Everybody agree?
Yeah.
Awesome. So if that's 120, that's good. And this arc here is 86. What measure of what angle do we know, Isabel?
Angle ABE would be 43.
You're saying this angle here is going to be 43?
Yeah.
Do people agree with that?
Uh-huh.
Yeah, because if this arc here is 86, then this angle which subtends it is going to have to be half of that, so that's 43. That's still not helping us find the measure of this angle, DEC, that we're trying to find.
Oh,
Maya.
Okay, so what you're doing is you find the angle AEB.
Angle AEB,
Yeah.
all right. This one?
Yes. You do 60 plus 43, which is 103. And then subtract 180 minus 103, and you get 77.
So are you saying this angle here is going to be 77
Yeah.
degrees?
And
Okay.
then that means that DEC is 77
Why?
because of the vertical angles.
Oh, yeah, vertical angles from like chapter 1. All right, so our answer here is going to be 77 degrees. Are we okay with that?
Yeah, how? Oh no, never mind.
All good?
Yeah.
All right, cool problem. I like it. Let's take a look at this theorem. This one says an inscribed angle subtends a semicircle if and only if the angle is a right angle. So if you have an angle, an inscribed angle that is a right angle, that angle that you draw is going to hit an arc, of course, and they're saying guaranteed that arc is going to be a semicircle. Are we okay with that? Does that make sense?
Yeah.
And that makes sense, because if this is a 90-degree angle here, this angle, oh my goodness, this angle here is a 90-degree angle, then what's the measure of this arc have to be?
180.
180, twice that, right? So this angle here has to be 180 degrees, and that makes it a semicircle, because it equals 180 degrees. Are we okay with this? All good? Okay. So let's take a look at this example. We're trying to find x in this picture here. You're looking at it, you're studying it, and I'm asking for your ideas on this. Angelina.
So you set it up to find the angle RQT. So you do 4x plus 6 equals 90.
So the measure of our RQT, first of all, let's stop for a minute. Angelina, I noticed that segment RT, which is a chord, is cutting through point S, which looks like the circle. True? So that's going to make arc RQT or arc, well, I guess this arc too, if I can throw another letter here, let me call it W, or the measure of arc RWT, those each have to measure what? 180. Would you agree with that, everyone?
Yes.
All good?
Yeah.
And so then, that means that the measure of angle RQT, that's this angle, must measure what, Devin? Do people agree with 90?
Yes.
All right, so this angle here must be a right angle, therefore. All right, so now that we know it's a right angle, how are we going to solve for x, Alex? So 4x plus 6 equals 90, and we're solving 6 equals 90. I'm subtracting 6 from both sides. I'm getting 4x equals that 84.
Yeah.
And dividing by 4 is that 21.
Yeah.
Are we okay with this?
Yeah.
All right, let's take a look at this next example here. In this case, we're trying to find y. I see that angle ABC looks like it measures 10y minus 28. True?
Yeah.
And I see that angle ADC measures 7y minus 1. Do you agree with that?
Yeah.
Yeah.
Yes, Nathan Slattery.
I was gonna.
Go ahead. What do you got?
Would they equal each other then?
Why would they have to equal each other?
Because
Oh, they point to the same.
Yeah.
On the same one. Okay.
they're both.
You say. You got some words.
No, I don't really. Well, they both. They're both on the same points.
Same one. They both end on the same
Yes.
points of the arc.
Yeah, and what's that word I said, oh, we're probably not going to use it. Maybe we need it now. Subtends. Where's my word? So the arc subtends the angle. All right, so maybe I don't want to use that because it's the other way around. But I would say, whoopsie, back here, I would say both of these angles have the same intercepted arc. Nathan, would you agree with that?
Yes.
All right, so they both have this arc AC as its intercepted arc. That means that they are both going to be, they're going to be congruent angles. Agreed?
Yes.
All right, so are you setting these equal to each other
Mhm.
and solid?
Yeah.
I don't know, I'm gonna subtract 7y from both sides, I'm adding 28 to both sides. Getting 3y equals 27,
Yeah.
and I'm getting y equals 9. Are we okay with this?
Yep.
Devin, you good?
Yeah.
All good? Okay. Moving on?
Yep.
All right, so now we have this theorem, another cool theorem. If
Yeah.
a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. First of all, what does it mean for a quadrilateral to be inscribed in a circle?
It's inside of it.
It's inside of it, I hear.
Yeah.
So let's say I have this circle here. Is this quadrilateral inscribed in the circle?
Yeah. No.
I hear yes, I hear no, from the same person, in fact. What's not on the outside?
The points are
Not
not.
in a circle.
So is this quadrilateral inscribed?
No.
What's got to be on the circle?
All the points.
Let's use a word that's not points. That's the vertices. All right, so the vertices have to be on the circle. So I would need to have my quadrilateral maybe looking like this. Everybody with me?
Yeah.
All right, so if the vertices of the quadrilateral are all points on the circle, then it is inscribed in the circle. And if that's the case, yes,
No,
Rachel,
never mind.
you're good?
Yeah.
If that's the case, then this quadrilateral is specially formed because the opposite angles are going to be supplementary. So if I call this A, B, C, and D, then I would know that the measure of angle blank plus the measure of angle blank is going to be equal to 180. Can you fill those blanks in for me, Maya?
The measure of angle B plus the measure of angle C.
All right, measure of angle B plus the measure of angle D. They're not equal to each other, but they add up to 180, right? They're supplementary. And then likewise with the measure of angle A plus the measure of angle C, that's going to add up to 180 as well. Are we okay with this?
Yes. Can I
Awesome.
do the next one?
What next one? This one?
Yes.
In this picture, it says find the angle measures of this whole quadrilateral. So we do have an inscribed quadrilateral here. It goes from P to point Q to point R to point S. And oh my goodness. And they're giving us the measures, I guess, in terms of Y for 2 of these. Connor, what do you got?
So the first thing I did was since 6y plus 1 and 10y plus 19 are opposite,
Yes.
I put them equal to, I add them up and set them equal to 180.
So are you saying that the measure of angle P plus the measure of angle R equals 180?
Yes.
Yes? So that's the 6y plus 1 plus the 10y plus 19 equals 180?
Yep. So
Okay.
16y plus 20 equals 180.
Okay? So 16y equals 160?
Yep. And then y equals 10.
Are we okay with y equaling 10?
Yep.
So now we can plug 10 in, and we get 6 times 10,
61.
61.
And then 119.
10 times 10 plus 19, 119.
And then,
Those add up to 180.
yep. And
Okay.
then the next one is 148.
Are you saying the measure of angle Q is going to be 10 squared plus 48?
Yes.
So that's 148.
And then what I did, because the opposite angles are supplementary, to find angle S, I subtracted 148 from 180.
Okay? And you got
32 degrees.
32. Are we okay with that? All good?
Yeah.
Easy.
Cool theorem.
Wait, hold on.
Problem. Is that it?
Wait, can you go back?
Can you go back for a second?
All right. So
Oh, wait, stop.
that's it for this lesson.
Stop recording.
Thanks for watching.
Happy birthday.